Hello students, welcome to Crack Academy. So today we are starting a beautiful journey of learning chemistry. So let me first introduce myself. I am Dr. Meeti Gaur and I am teaching chemistry since last so many years. So what impression I get from the student that chemistry is a history of mystery of elements. Is it so? Not at all, students. If you study chemistry by connecting it with day to day life, you find that chemistry is not a history of mystery. Rather, it is a beautiful subject. We have to study the basic things regarding the chemistry. If we have the clear concept of the topics involved, then we will be inculcating the habit of doing things from the basic level and then understanding, getting the concepts and practicing them, and your sincere regular efforts will bring you a good result. So for me, chemistry is in my nerves, my blood. So let me make it a favorite subject of yours. So students, in plus one, we have to study, in plus one chemistry, we have to study the different streams of chemistry. Like the whole chemistry is divided into three classes: physical chemistry, inorganic chemistry, and organic chemistry. In physical chemistry, we have to study all the phenomena process involved in the occurrence of the chemical reactions. Like in plus one, we will study the structure of atom, then basic concepts of chemistry in which we will be doing mole concept, then thermodynamics. It is the chemistry related to the heat energy changes involved in the chemical reactions. Then we will study about the equilibrium, both chemical and ionic equilibrium, and then we will study about the redox reactions. These are the lessons of physical chemistry which we are supposed to do in plus one. Then next come to the inorganic chemistry. Inorganic chemistry is the study of the elements and their compounds of the periodic table apart from carbon, because the study of carbon and its compound is allotted a separate branch of chemistry, that is the organic chemistry. So in plus one, let's talk about inorganic chemistry first. We will be doing the periodic properties of elements. Some of that part you have already done in lower classes. After that we will do chemical bonding and then the P block elements in detail. But in plus one we have only 13 and 14 groups. Rest of the groups of the P block we will do in plus 2. Now come to the organic chemistry. In organic chemistry, we have to study about the carbon and its compound. Remember, in last class, you have studied about the lesson carbon and its compound, nomenclature of functional group, alkanes, alkenes. These you have done in 10th standard. I hope you have enjoyed that in 10th standard. And now we will be further continuing these concepts in plus one also. So in plus one organic chemistry, first we will do the nomenclature. Earlier you have done a bit, but now we have to do it in detail. After that, we will talk about isomerism, then general organic chemistry, purification and characterization of organic compound, that which elements are present in the organic compounds and what is the percentage composition of all elements in the organic compound, that we have to do in the lesson purification and characterization of organic compound. And the next lesson is hydrocarbon, in which we will study about the physical properties, chemical properties and preparation of alkanes, alkenes, alkynes and benzene. So this is what we have to do in plus one, not a bit but a lot. Okay, so let's start. Today I'm starting with my first lesson of physical chemistry, and that is the structure of atom. So, structure of atom. All of you are aware this structure of atom. So, till now, what you have studied, the atom consists of positively charged dense core called nucleus, and the negatively charged electrons are revolving around the nucleus. So whatever the concept about the structure of atom you have studied till now, what is the chronicle sequence of the development of the different steps involved in establishing the structure of atom that you have studied till now? Then what are the failures of this method? And what is the actual structure of metal atom that we are going to study in this lesson? So let's discuss about the journey of the different step in which the actual today's model of atom is studied. So students, the first attempt regarding the structure of atom was given by J.J. Thomson. In 1994, J.J. Thomson has given his plum pudding model, planetary model of an atom. According to him, the whole positive charge of atom is concentrated in the spherical region and negatively charged electrons are embedded in it. This was the first ever known structure of atom till now, which was given by J.J. Thomson. There were some drawbacks in the plum pudding model. So another model of atom was proposed, and that model was proposed by Rutherford in 1911 by performing the alpha particle scattering experiment. But still, the alpha particle scattering experiment performed by Rutherford has certain limitations, certain drawbacks. To overcome those drawbacks, the Bohr has introduced another model of an atom in 1913. Bohr proposed this type of model of an atom. There is a centrally located positively charged dense core in which nucleons, neutrons and protons are present, and the negatively charged electron is moving round the nucleus in circular path called as orbits. This model was proposed by Bohr. But students, do you know, even the Bohr model has some drawbacks or certain failures. Why? Because still here, the structure proposed by the scientist was 2D model. 2D model, that means they have proposed the flat two-dimensional model of an atom. But the structure of atom is 3D. Three-dimensional structure of atoms was proposed by Erwin Schrödinger. Erwin Schrödinger was the scientist who laid the foundation of the quantum mechanical model of an atom, and this quantum mechanical model of an atom is he given his quantum mechanical model of an atom in 1926. So step by steps we are studying the structure of atom, and one atom structure proposed atom has drawbacks. These were overcome by the another scientist, and simultaneously the chronological developments are taking place, and ultimately we are getting the 3D model of an atom. 3D model of an atom, this is like beehive structure. This is also called as electron cloud model. In this you can see this is the nucleus and electron are moving around the nucleus in form of electron cloud. No fixed position is assigned to an electron in 3D model of an atom. It moves around the nucleus in form of electron cloud. So this 3D model of an atom has beehive like structure. Do you know beehive? It is a hive in which the bees are continuously moving in that hive. So that is called as a beehive. Similar model is proposed by the Erwin Schrödinger for an atom, that is called as the quantum mechanical model of an atom. So step by step we will be studying about the different efforts made by the scientists from Thomson model to the Irwin-Schrödinger model. That is from 2D model to 3D model of an atom, which is known at present. So let's start. First, I will tell you about the years in which some of the important developments were made when the structure of atom was studied. First is the discovery of cathode rays, 1879. So cathode rays discharge tube experiment was performed by William Crookes in 1879. After that, discovery of anode rays, that was done in 1896. Then electron was discovered in 1897. Then Thomson model, plum pudding model, was given in 1904. And after 5 years of the Thomson model, Rutherford experiment was performed, and Rutherford proposed his model in 1909. After the Rutherford model, the proton was discovered. Proton was discovered in 1907 by Rutherford. And after the discovery of proton, neutron was discovered. In 1932, neutron was discovered by James Chadwick. Now, we will be studying about these different experiments and the discoveries made by the electron for establishing the recent structure of an atom. So let's start with the first experiment, that is discovery of cathode rays, William Crookes discharge tube experiment, which was performed in 1879. Cathode rays, which later on led to the discovery of electron. This cathode ray experiment was performed by William Crookes. What William Crookes did, he took a discharge tube. First, he evacuated the discharge tube. Evacuated means with the suction pump or the vacuum pump, he sucked all the air and moisture present in the discharge tube, then filled the gas in the discharge tube. He coated the inner lining of the discharge tube with a fluorescent material. Fluorescent material means it is a substance or it is a compound on which when light falls, it produces fluorescence. Have you ever seen this experiment or phenomena ever? Can you make it out? All of you have seen. Haven't you seen the tube light? Tube light that gives you light. The inner surface of the tube light is coated by the compound which produces fluorescence. So when the light, electric arc, is about to fall on that inner lining of the tube or the tube light, which has a property of fluorescence, then when electric arc is bombarded, then they produce glow that we observe in form of light. Even the television picture tube, that also is based on this concept of producing fluorescence. So he coated the inner lining of the discharge tube with fluorescent substance and took two electrodes. One electrode which he connected to the positive terminal he called as the anode, and other negative terminal to which the electrode is connected, that is called as a cathode. Then in this experimental setup, he filled the gas at 1 atmospheric pressure and passed the potential of 10,000. That means when he passed 10,000 volt potential at 1 atmospheric pressure, he observed nothing. No observations was made by William Crookes. Can you conclude why this is happening? Why he was observing no experimental facts at that time? Because air is a poor conductor of electricity at 1 atmospheric pressure. All gases are poor conductor of electricity at atmospheric pressure. So when he kept the pressure as 1 atm, he doesn't observe any observation in his experiment. Then what he did, he keep on reducing the pressure in the discharge tube. When the pressure in the discharge tube was reduced to 0.01 mm of Hg, pressure was 0.01 mm of Hg, and he passed the potential of 10,000 volt. High potential is passed. Then he observed that the walls of the discharge opposite to that of cathode starts glowing. That means he was observing the glow on the walls of discharge tube, which is opposite to that of the cathode. Then he observed that this glow was produced due to the emission of certain rays from the cathode, which passed through the metallic anode and bombarded the walls of the discharge tube and produced fluorescence. Since these rays were emitted from the cathode, he called these rays as the cathode rays. So let me tell you how cathode rays were formed. When sufficiently high voltage is applied across the electrodes and the pressure is reduced to very low value, 0.01 mm of Hg, the current starts flowing through a stream of particles moving in the tube from negative electrode, that is cathode, to positive electrode, anode, and these were called as the cathode rays or cathode rays particle. That means these which are moving towards the positively charged electrode, passing through the positively charged electrode and producing fluorescence on the walls of the discharge tube. This is how cathode rays were discovered by William Crookes. Now, the flow of current from cathode to anode was further checked by making a hole in the anode and coating the tube behind the anode with ZNS. Zn is the substance which produces fluorescence. So even the hole is produced, even the cathode rays were passing through the metal plate and they are producing fluorescence. When these rays after passing through the anode strike the ZNS coated, a bright spots on the coating is developed. And due to this fluorescence or bright spots, the cathode rays were discovered. Now the question arises, what is the origin of the cathode rays? So, initially, we are taking, suppose, a gas in the discharge tube. A gas is taken in the discharge tube. Now, when these A gases atom are striked with the cathode rays, initially cathode rays emitted from cathode. Initially, the cathode rays were emitted from cathode. They were emitted from cathode. Later on, what happens when these cathode rays strike the gaseous atom? The gaseous atoms are filled in the discharge tube. Gas was there and gas consists of atom. When cathode rays strike these gaseous atom, then these rays knock the electron out from the gaseous atom, converting these gaseous atoms to ions. This is the beam of knocked out electron. Here I have shown with reference to only one electron, but so many gaseous atoms are there and all gaseous atoms are struck by the cathode rays which initially emitted from the cathode, and these rays knock the electron out from the gaseous atom and convert them into the positively charged ion, and this knocked out beam of electron moves towards the oppositely charged electrode in form of rays which we call as cathode rays. So if I ask you, students, what is the origin of cathode rays? You will say initially the cathode rays were emitted from the cathode, and later on cathode rays consist of knocked out electron beam from the gaseous atom, converting them into the positively charged ions. So in this way, the cathode rays were discovered by William Crookes. Now, the properties of the cathode rays were studied by J.J. Thomson. So now we are going to study about the properties of the cathode rays, and these properties of the cathode rays were discovered by Thomson. Discovered by William Crookes, but properties were studied by Thomson. So students, what are the properties? These rays start from anode and move towards anode. They were emitting from the negatively charged electrode and moving towards the positively charged electrode. So what inference can be taken from this? That cathode rays are negatively charged in nature, since they are moving towards the positively charged anode, which is indicating that cathode rays are negatively charged in nature. So these cathode rays are first produced from the material of the cathode. Initially they originated from the cathode and then from the gas inside the discharge tube due to the bombardment of gas molecule by high speed electrons emitting from the cathode. This I have already explained in origin of cathode rays. They produce a sharp shadow of an object placed in their path. This shows that cathode rays travel in straight line. This is the same phenomena, students, as we observed in day-to-day life. Why shadows are casted? You have studied in lower classes that shadows are casted when any object comes in path of light. The light is traveling straight. When any objects come in path of light, the light rays are not able to penetrate through it. That is why the shadow of that object is casted. Similar happening is observed here also. They produce a sharp shadow of object placed in their path, and this shows that cathode rays travel in straight line. Then cathode rays consist of material particle. They are consisting of material particle. How do he came to know that cathode ray consists of material particle? So what J.J. Thomson did, he took a light paddle wheel. Have you seen the paddle of the cycle? Similar type of paddle wheel he is taking, and this paddle wheel is having very less friction. This paddle wheel he took, and on this paddle he passed the cathode rays. These cathode rays move the pedal wheel. The pedal wheel start moving when cathode rays strike. From this it is concluded that the cathode rays consist of material particles. So cathode rays consist of material particles. Now when the electric field is applied or the magnetic field is applied to the cathode rays which were produced, when the external electric field is applied and the external magnetic field is applied, the cathode rays are showing deflection towards the side in which the negatively charged particles are showing deflection. So the region in which the negatively charged particles are showing deflection, in the same region the cathode rays are showing deflection, which shows that cathode rays are negatively charged in nature. Then the above properties, it is concluded that cathode rays are made up of negatively charged particles called as electron. So electrons was discovered by J.J. Thomson from cathode rays when he studied the properties of cathode rays, but name of electron as electron by Stoney, discovered by J.J. Thomson but named by Stoney. Then cathode rays are themselves not visible. Cathode rays are invisible. How then their presence is detected? When they are bombarding the walls of the discharge tube opposite to that of cathode. But the fluorescence or the fluorescent will glow when these rays hit them. They produce heating effect. When an object is placed in the path of cathode rays and the cathode rays are bombarded on that object, then after some time the object becomes hot, which shows that cathode rays produce heating effect. Then they ionize the gases through which they pass. This is very important point. Ionize the gases through which they pass means if the hydrogen gas is taken in the discharge tube under high H atom, and when these H atoms are hit These cathode rays knock the electron out from the gaseous atom, converting them into positively charged ions. That means atoms are converted into ions by knocking off electron out. So we can say that cathode rays ionize the gases through which they pass. And very important point, students, that you have to keep in mind, when cathode rays strike heavy metal, they produce X-ray. You might have seen this phenomena in the hospitals. Whenever the fracture is there, the people go to hospital for detecting whether the fracture has taken place or not. So they used to do, doctors used to do the X-rays. In X-rays, what they did, they passed cathode rays over heavy metals, due to which X-rays were produced, and these X-rays are passed through the body. So the property of X-ray is this, that they cannot penetrate through bones. So if there is fracture in the bone, then cathode rays or X-rays will pass through that broken part, and rest of the part they will be not penetrating through, which helps in the detection of the fractured bones. So they produce X-rays on striking heavy metals like tungsten. They can penetrate through thin metal sheet. How can you make it out that cathode rays can penetrate through thin metal sheet? Because the cathode rays are passing through the thin metal anode and is producing fluorescence on the walls of discharge tube. From this we can conclude that cathode rays have high penetrating power. So the characteristic of cathode rays do not depend of the material of the electrons or the nature of gas present in the discharge tube. Student, this is one of the very important point. The characteristic of cathode rays. Later on we will say specific charge. What type of cathode rays are obtained? It is not depending upon the nature of gas taken in discharge tube. If we take hydrogen gas in the discharge tube, the cathode rays produced will be same. If we fill the discharge tube with nitrogen gas, the cathode rays produced will be the same. So the nature of the cathode rays is not depending upon the nature of gas taken in discharge tube. Why? Because cathode rays are consisting of a knocked out electron beam from gaseous atom. So whatever be the gaseous atom, we are not bothering about that. We are only talk about the knocked out electron beam. And knocked out electron beam consists of electron, and electron is the basic constituent of all matter. And since cathode rays consist of electron, so the nature of the cathode rays will remain same irrespective of gas taken in discharge tube. Then J.J. Thomson measured the electrical charge or mass. That we are talking about specific charge is the ratio of charge to the mass. So when J.J. Thomson measured the specific charge of the cathode rays, the specific charge of the cathode rays was found to be constant. It is 1.76 into 10 to the power 8 coulombs per gram, or it 1.6 into 10 to the power 11 coulombs per kg. So specific charge E by M ratio of cathode rays is constant and thus not depending upon the nature of gas taken in discharge tube. And what is the specific charge? It is 1.76 into 10 raised to the power 8 coulombs per gram in CGS, or 1.76 into 10 to the power 11 coulombs per kg in MKS. Then irrespective of the nature of gas inside the discharge tube, the material of the electrode, E by M, these particles constituting the cathode rays is same. I told you that specific charge of the cathode is constant. Cathode ray specific charge, this is constant. And it is not depending upon the nature of gas taken in discharge tube. Then the charge was determined by R.M. Millikan to be equal to minus 1.6 into 10 raised to the power minus 19 coulombs in MKS system, and this charge was minus 4.803 into 10 raised to the power minus 10 ESU in CGS system, and this is also called as unit negative charge. The smallest negative charge was which a species can acquire is called as a unit negative charge. So these are the properties of the cathode rays. From the properties of cathode rays, J.J. Thomson discovered electron. So we will talk about the properties of electron. Electron is the fundamental particle of an atom. It is called as subatomic particle. It is subatomic particle which is the fundamental constituent of all matter. Then second, the electron was discovered by, cathode rays were discovered by William Crookes, while the for the electron was given to J.J. Thomson, and these were named by Stoney. Then a unit negative charge is present on the electron, and I told you the negative charge of the electron is 1.6 into 10 raised to the power minus 19 coulombs in MKS system, and this charge was calculated by R.A. Mulliken. R.A. Mulliken calculated the charge of electron by his oil drop experiment that you will study in physics, and calculated the charge as this in MKS and this in CGS system. And which is the experiment? Oil drop experiment. Then the specific charge E by M of cathode rays will be same as that of electron. Electron and cathode rays have the same specific charge because cathode rays consist of electrons. So specific charge is 76 into 10 to the power 8 coulombs per gram. Then I told you the value of specific charge, E by M is specific charge. With the help of this, knowing the specific charge and charge, then the mass of the electron was calculated. It is E by M, this is the specific charge, divided by, it is E charge divided by E by M. The charge is cancelled out. So mass of the electron was calculated as 9.1 into 10 to the power minus 28 grams. So mass of the electron is 9.1 into 10 to the power minus 28 grams. It is calculated by taking the ratio of charge and specific charge. And this mass of electron is 0.00054 AMU. It is 1 upon 1837 types of hydrogen atom. Mass of electron is 1 upon 1837 times the mass of proton. That means electron is the lightest fundamental subatomic particle. And this mass of the electron is called as rest mass. This is the rest mass of the electron when the electron is not moving. If we have to calculate the mass of moving electron, then mass of the moving electron in motion is calculated by the formula m rest, mass of rest electron divided by root of 1 minus v upon c the whole square, where v is the velocity of electron and c will be the velocity of light. In this way, we can calculate the mass of electron, and when electron moves with the velocity of light, its mass will become infinity. So these are the properties of the electron about which I have told you. So from the cathode rays, electron was discovered. Now after the cathode rays, 1 year after the William Crookes experiment, Goldstein performed the same experiment for the discovery of anode rays. So now we are going to study about the discovery of anode rays that led to the discovery of proton. So the experiment was the same as performed by William Crookes. The only modification that was done in the experiment is by taking perforated cathode. That means this cathode is having holes in it. Metal plate having holes in it. That is called as the perforated cathode. So the same experiment was performed What was the experiment? The gas is filled in the discharge tube and high potential of charge, that is approximately 10,000, is passed through the gas at 0.01 mm of Hg at very low pressure, and then he observed that glow was produced on the walls of discharge tube opposite to anode. This was earlier discovered by William Crookes. But in this experiment, the glow was observed on the walls opposite to that of anode. This glow was not observed by William Crookes. This was observed by the Goldstein by taking perforated cathode. Why the William Crookes was not able to observe this glow? That is due to the emission of the anode rays, which have low penetrating power. When cathode rays were produced, simultaneously the anode rays were also produced. But anode rays have low penetrating power. They were not able to pass through the metal cathode and produce fluorescence. That is why the William Crookes was not able to discover the anode rays. But when the Goldstein modified the experiment and he took perforated a cathode, then these rays are passing through the holes of the perforated cathode, bombarding the walls of the discharge tube opposite to that of anode, and are producing glow or fluorescence. In this way, Goldstein discovered anode rays. Now, since these rays were passing through the holes, these are the holes, these rays were passing through the holes, so he called these rays as the canal rays. The anode rays were also called as the canal rays. And how these canal rays were produced? When a high potential difference was applied between the electrodes, not only cathode rays produced, but type of rays moving towards the cathode rays were also observed, which passed through the holes in the cathode and produced green fluorescence on the opposite coated with ZNS, and these were called as anode rays or positive rays. Now the question arises, how these rays are formed? Cathode rays, we know, they consist of knocked out electron beam. Then what is the origin of the anode rays? Let me explain you. So let's see, if hydrogen gas is taken in the discharge tube and this hydrogen gas is knocked out by the cathode rays, then cathode rays knocks the electron out from the gaseous atom, converting them into the positively charged ions, and these positively charged ions constitute the anode rays. If we took the helium gas, when cathode rays strike helium gas, it will knock the electron out from helium atoms, converting them into the positively charged ions. If we take X gas, the cathode rays strike the X gaseous atom, again knocks the electron out from the gaseous atom, converting them into the positively charged ions, and these positively charged ions are constituting the anode rays. So anode rays consist of positively charged ions formed after the knocking of electron out from the gaseous atom when cathode rays strike them. So student, can you see? These knocked out electron beam are forming cathode rays and these positively charged ions are forming anode rays. That means the nature of the anode rays is depending upon the nature of gas taken in discharge tube. If H2 gas is taken, then anode rays consist of H positive. If helium gas is taken, then anode rays consist of He2 positive ions. If X gas is taken, then anode rays consist of Xn positive ion. That means the nature of the anode rays depends upon the nature of gas taken in discharge tube. So these rays are produced as a result of electrons from the gaseous atoms by bombardment of high speed electron of the cathode rays on them. They are not emitted from the anode but produced between the space between anode and cathode. Cathode rays were originated from the cathode, but anode rays were not originated from the anode. They are produced by the ionization of gaseous atom when the cathode rays strike these gaseous atoms. Then properties of the anode rays. The rays contain the positively charged gaseous ion. Since these ions are positively charged in nature, they will move towards the negatively charged electrode. The nature of the positively charged particles depends upon the nature of gas taken in discharge tube. I told you that when we change the gas in the discharge tube, the nature of the positively charged ions is going to change. So we can say nature of the anode rays depends upon the nature of gas taken in discharge tube. Some of the positively charged particles carry a multiple of fundamental units of electric charge. For H gas, the positively charged species carries 1 unit of charge. For He gas, the positively charged species carries 2 units of charge. So the constituent materials of the anode rays carries the multiples of unit charge or simple unit charge. So some of the positively charged particles carry a multiple units of electrical charge. The charge to mass ratio, that means E by m ratio of anode rays, E by m ratio of anode rays is not constant. Rather, it is depending upon the nature of gas taken in discharge tube. And when hydrogen gas is taken in the discharge tube, present in the anode rays have maximum mass, and the E by m base ratio is particle is 9.58 into 10 to the power 4, and this is the E by m ratio of the proton. Student, if hydrogen gas is taken, then hydrogen atom consists of 1 electron, 1 proton and neutron 0. Only species which is having 0 neutron in its nucleus. When cathode rays strike them, 1 electron is knocked out and converting them into the positively charged atom which is having only 1 proton. That is why the H positive is called as the proton. So when Goldstein filled the hydrogen gas in the discharge tube, he discovered proton, and the specific charge of the proton was found to be 9.58 into 10 to the power 4 coulombs per gram. The behavior of these particles in the magnetic field and electric field is opposite to that of cathode ray. Since cathode rays were deflecting towards the side in which the negatively charged species are showing deflection in the external and magnetic field, similarly, the anode rays are deflected in the direction in which the positively charged species are deflected on application of external electric and magnetic field. From this, it can be concluded that anode rays are positively charged in nature. The smallest and the lightest positive ion was obtained from the hydrogen atom and is called as proton by Rutherford. So, who named proton as proton? It is Rutherford, and discovered when H2 gas is filled in the discharge tube. Then, the charge of the proton is, the atom is electrically neutral and the negatively charged particles were discovered, that is the electron. And since atom is electrically neutral, that means in an atom there must be the positively charged particle, and the charge of those positive charged particles should be equal to that of the electron. So we have concluded that the charge on the proton, smallest positively charged particle, is plus 1.6 into 10 raised to the power minus 19 coulombs in MK system, or plus 803 into 10 raised to the power minus 10 ESU in CGS system, and its mass was calculated by as 1.67 into 10 to the power minus 24 grams. It is heavier than electron. The mass of electron is 1 upon 1837 times of the proton. That means proton is more heavier or much heavier in comparison to proton. A proton is a subatomic particle which carries 1 unit positive charge and mass nearly equal to that of hydrogen atom. Mass of the proton is same as that of hydrogen atom. Why? Hydrogen atom has 1 electron and mass of the electron is very less. So when the hydrogen from hydrogen atom 1 electron is taken out, it is converted into proton, and since the mass of electron is negligible, so removal of electron is not going to affect the mass of proton. So mass of the proton is almost same as the mass of hydrogen atom. So students, till now we have discovered the negatively charged particles, that is electrons, and positively charged particles. They were not called as protons till now. Till Thomson model, the protons were not named as the protons. It was only known that the atom is carrying integral multiples of positive charge. The protons was not discovered by this time. Only the positively charged particles were discovered. And since atom is electrically neutral, so it was concluded that total units of positive charge in an atom are equal to total units of negative charge. Now at that time, the different attempts were made. What is the distribution of electron and these positively charged particles in an atom? So first attempt was taken by the Thomson. First ever known model of an atom was proposed by Thomson in 1904, and he named his model as Thomson atomic model, which is also called as Plum or watermelon model. Why watermelon? As you can see in watermelon, there is a positively charged core and the black seeds are embedded in that positively charged core. Same concept Thomson gave for his model of an atom. In an atom, whole positive charge. Positive charge is due to the positively charged particles. So, the positive charge of all positively charged particles is uniformly spread in a core, and negatively charged electrons are embedded in that positively charged cores as the black seeds are embedded in watermelon or the plums in pudding. So, he called his model as plum pudding model or watermelon model. So, let's see what Thomson said. Thomson was the first to propose a detailed model of an atom. Thomson proposed an atom consists of a uniform sphere of positive charge in which the electrons are distributed more or less uniformly. This model is known as plum pudding model or raisin pudding model or watermelon model. You can see here. But this has certain limitation, not certain, a lot of limitation. And what are those limitations? That this model was not able to explain the overall neutrality of an atom. It is explaining why atom is electrically neutral, but it could not explain the result of ionization and scattering of alpha particle experiment. Soon after Thomson model, after 5 years, Rutherford performed an alpha particle scattering experiment, and the results of alpha particle scattering experiment were 100% contradiction with the Thomson model. So his model was discarded. Had the Thomson model has been correct, so when Rutherford performed the alpha particle scattering experiment, if this model would have been correct, then scattering of alpha particle would have been like this. That means very less alpha particle should be deflected. But we are seeing the totally different results from Rutherford alpha particle scattering experiment that we will study in next lecture. So, had the Thomson model been correct, the large number of positive particles should have suffered small deflection. But alpha particles are showing large deflection. And why alpha particles are showing large deflection? Thomson was not able to offer any explanation. So these are the drawbacks of the Thomson's plum pudding model. After that, the Rutherford performed his alpha particle scattering experiment, but that we will do in next lecture. In this lecture, I will first explain you all the three types of subatomic particle. I have explained you electron, I have explained you proton. So third subatomic particle is neutron. Discovery of neutron. Neutron was discovered much more later after discovery of proton. It was discovered in 1932 by James Chadwick. Who discovered neutron? James Chadwick. After the discovery of proton and electron, it was noticed that all not be due of these particles. When the mass of the atom was calculated, earlier it was said that atom is having electron and proton, and electron has negligible mass. So when the mass of the atom is calculated, and that should be the sum of the total masses of the protons. But when actually the mass of the atom was calculated, it was found that the mass of atom is almost double the mass of the sum of the protons. That means if the sum of the proton mass is x, and when mathematically the mass of atom is calculated, it was coming out to be 2x. Electrons are having negligible mass. So this led to the conclusion that apart from the electron and proton, some other type of subatomic particles are also present in an atom, and the mass of these particles is almost same as that of proton, because mass of the atom is coming out to be double the sum of the masses of the proton. That means the mass of the subatomic particle that was not discovered at that time should be comparable to that of the proton, and that should carry zero charge, because in an atom the total units of negatively charged electron are balancing the total units of positive charge. So the third subatomic particle should be discovered whose mass should be comparable to that of proton, and it should be neutral. So before the discovery of neutron, the neutron was named as neutron because the scientists have made the conclusion that this subatomic particle should be neutral. So named as neutron. So it was discovered by James Chadwick. The problem was solved by of another subatomic particle called neutron. A neutron was discovered through the nuclear reaction in which nuclei of larger particles like beryllium or boron were bombarded with high speed alpha particles. Now what James Chadwick did, he took beryllium and boron nuclei and on that he bombarded alpha particles. Students, alpha particles are the positively charged helium nuclei having mass 4 times that of protons and carries 2 units of positive charge. So he bombarded these alpha particles on the beryllium atom. In this, the carbon atom is formed along with the emission of third type of subatomic particle, that is the neutron. The charge of the neutron is 0 and its mass is 1 AMU, same as that of proton. So what are the characteristics of neutron? It is a fundamental part of atom which is present in the nuclei of all atoms except hydrogen and protium. H11, protium is the only atom known which is not having any neutrons in its nuclei. Then it was discovered by James Chadwick in 1932. It is a neutral particle. It does not have any positive or negative charge on it. The mass of the neutron is almost equal to that of the proton. Although it is slightly heavier than the proton, the mass of proton is 1.67 into 10 to the power minus 24 grams, whereas that of neutron is 1.675 into 10 to the power minus 24 grams, slightly heavier than proton. Heavier than proton, its mass is 1.6748 or 1.65 into 10 to the power minus 24 grams, approximately as that of the proton. Neutron is relatively heavier out of the 3 fundamental particles. Molar mass of the neutron is obtained by multiplying the mass of neutron with Avogadro's number, and this was found to be 1.00893 grams. This we will discuss in whole concept. So till now it was known that atom consists of 3 fundamental subatomic particles which are electron, proton, neutron. How these subatomic particles was discovered and what are the characteristics of these subatomic particles, I have told you. Let's summarize now. There are 3 types of subatomic particle: electron, proton, neutron. Symbol E. For proton, P. For neutron, it is N. Approximate relative mass. The mass of electron is 1.1837 times that of the proton. Proton is taken as 1, then neutron mass is almost same as that of proton, it is 1. Then approximate relative charge. Electron is carrying 1 unit of negative charge, whereas proton is carrying 1 unit of positive charge. And neutron is neutral. It is carrying 0 charge. Then mass in kg. For 9.1 into 10 to the power minus 31 kg. For the proton is 1.67 into 10 to the power minus 27 kg. And for the neutron is it 1.675 into 10 to the power minus 27 kg. So this is most heavier subatomic particle, then proton, then electron. Mass in AMU. It is 5.48 into 10 to the power minus 4 AMU. And the mass of the proton in AMU is 1.007 AMU. And that of neutron is 1.008 AMU. And actual charge, it is minus 1.6 into 10 to the power minus 19 coulombs for electron, plus 1.6 into 10 to the power minus 19 coulombs for proton, and it is 0 for neutron. So these are the characteristic of subatomic particles. Students, all I have to learn about these characteristics. In numericals, these values may or may not be given. Sometimes it is assumed you might be knowing the mass of electron, you will be knowing the charge of electron. So these characteristics of the three fundamental subatomic particles you have to keep in mind. So this is all about the detailed discussion of the three fundamental subatomic particles. Let's do some of the questions related to it. Now the problem is, student, all of us know that mass of the electron is negligible and mass of proton and neutron are almost same. So question is, if mass of the neutron is doubled and mass of the electron is halved, find out new atomic mass of carbon present in which it is increased. Students, all of us know carbon, it has 6 protons plus 6 neutrons. And the mass of electron is negligible. So the mass of carbon is almost 12 AMU. Mass of the carbon is 12 AMU. Now in the given question, they are saying mass of the electron is halved. No effect, because mass of electron is negligible. Either you halve it, you double it. The mass of electron is not going to affect the mass of an atom. But the mass of neutron, that means if the mass of the proton is 6 and the mass of the neutron is doubled, that means 6 into 2, it will become 12 AMU. So mass of neutron will become 18 AMU. Now they are asking what is the change in the new mass of the carbon atom. So not mass of the electron is negligible, so it is not considered. So percentage increment, increase in mass when mass of the neutron is doubled. The new mass of the neutron was, carbon was 18. This is final mass. Initial it was 12 divided by the original mass. So increase in mass of the carbon atom will be 50% when mass of the neutron is doubled. Next question is, arrange electron, proton, neutron and alpha particle in decreasing order of their specific charge. Electron, charge, we have to in decreasing order of their specific charge, that is E by M. Students, from this can we conclude that E by M ratio is inversely proportional. The sub or the species which is having lowest mass will have lowest specific charge. So if I arrange the species in increasing order of their masses, the minimum masses of electron, mass of electron is minimum, then is the mass of proton, then is the mass of neutron, then is the mass of alpha particle. बच्चे alpha particle 4 times that of proton. So this is according to mass. So what will be the E by M ratio specific charge? Student, we know that charge of neutron is 0. So E by M of neutron, that is specific charge of neutron, will be also 0. So if I ask you to arrange these species in decreasing order of their E by M ratio, then the species which is having minimum mass will have maximum E by M ratio. So maximum specific charge will be for the electron, then will be for the neutron. then it should be for neutron. But since the neutron is having zero charge, specific charge is also zero. So it is alpha particle. After that it is neutron. It is having least, that is zero specific charge. So this is how I have arranged these species in decreasing of their E/m ratio. Next. One good question I have given you, students. And the question is, arrange these in decreasing order of their specific charge. That means E ratio. So student, first I am taking C12,6 charge 1. If I talk about, if I take C12,6 plus 2, now the charge is, and if I talk about C14,6 plus, its E/m ratio will be 1/14. And if I take C14,6 plus 2, then its E/m ratio will be charge. So student, can you see? I have taken the E/m ratio of the given species and I'm asking you to arrange them in decreasing order of their E/m ratio. So student, the numerator is same for the species. The species having minimum denominator will give maximum value. So the maximum value should be of this species. That is, it is C12,6 plus 2 and its E/m ratio will be 1/6. Then it will be 6 E/m ratio 7. Then it will be C12 plus 1 or plus 2, 6. Its ratio will be 1/C14. It is 1 by, it will be 2/14. It will be 1/12. It is 12. And then it is C plus, it is 12, 6. It is 1/14. Is it okay? So this is the decreasing their E/m ratio. So students, till now we have studied about the three types of subatomic particle in detail, talked about their specific charge, their discovery, their properties. So in next lecture we will be studying about the Rutherford alpha particle scattering experiment. I hope all of you might have enjoyed this lecture, isn't it? So carry on. Have a good day. Hello students, welcome to Crack Academy. So earlier we have studied about the three subatomic particle, electron, proton, neutron, their discovery, their properties, their characteristics. Then we have studied about the Thomson's plum pudding model. Thomson's plum pudding model faced a serious blow when the Rutherford performed his alpha particle scattering experiment. So today we are starting with the second step in the developing of a structure of atom, that is the Rutherford alpha particle scattering experiment. So Rutherford alpha particle scattering experiment was performed by Rutherford in year 1909, immediately after the Thomson gave his plum pudding model. So in the Rutherford alpha particle scattering experiment, Rutherford used alpha particles. Alpha particles. Alpha particles are the beam of di positive charge, di positive charged helium nuclei. Earlier also I told you that alpha particles are represented by He4 2 positive. These are the di-positively charged helium nuclei. That means alpha particles are positively charged. So in Rutherford alpha particle scattering experiment, Rutherford took 0.001 millimeter thin gold film. He bombarded the alpha particle from the radioactive source on this film and observed the deflection of alpha particles. He took this circular screen, which is coated with, inner lining of this screen is coated with the fluorescent material. So whenever any particles strike those fluorescent material, they produce fluorescence. So when Rutherford bombarded alpha particles in 0.001 millimeter thin gold film, the alpha particles were deflected, which were observed by this circular fluorescent substance coated screen. When he observed the deflection of these alpha particles, the following observations were made by Rutherford. Rutherford observed that most of the alpha particles went straight without any deflection. They are not deviating from their original path. Second observation, he said that some of the alpha particles got deviated from their path on colliding with the gold film. Most of the, you can see in the picture that most of the alpha particles are going straight without any deflection. Some of the alpha particles are showing deflection. That means they are bending through angle theta. Very few, 1 in 20,000, very few, 1 in 20,000 were either deflected back or they retraced their original path. So three observations he made, that most of the particles went straight without any deflection. Few of the alpha particles are bending through angle theta, and very few, like 1 in 20,000, were deflected back or retraced their original path. When Rutherford tried to study the reason of the deflection pattern of these alpha particles, he made the following observations. So now I'll tell you the conclusions from the observations of the Rutherford experiment. So based on the observations of his experiment, Rutherford gave the following conclusion. He said most of the alpha particles went straight without any deflection because most of the space in an atom is empty. So whenever the alpha particles are passing through empty space in an atom, they are going straight without any deflection. Then whole of the mass of atom is confined to its nucleus, which consists of positively charged protons and neutral particles. Now, how this conclusion was drawn by Rutherford? Alpha particles are the heavy particles. They are approaching some heavy body inside the nucleus. That is why they are undergoing deflection. On this basis, Rutherford concluded that since positively charged heavy alpha particles are deflecting through angle theta, that means they are approaching some heavy body inside the atom. Then since 1 in 20,000 alpha particles were deflected back or retraced their original path, that is due to the electrostatic force of repulsion experienced by the positively charged alpha particles. Since alpha particles are positive, then they are approaching some positive body inside the nucleus. Then there will be the force of repulsion, and due to this repulsion, the alpha particles are retracing their original path or bending through very high obtuse angles. On this basis, Rutherford concluded that in an atom there is centrally located positively charged dense core on which entire mass of the atom is concentrated. And this positively charged dense core consists of protons and neutrons, which are collectively called as nucleons. So the whole of the mass of atom is confined to the nucleus. And what is this nucleus? It is positively charged dense core. Positively charged dense core on which entire mass of the atom is concentrated, which consists of positively charged protons and neutral neutrons, which are collectively called as nucleons. And when he calculated the size of atom and the nucleus, he found that the radius of the nucleus is approximately 1 into 10 to the power minus 13 centimeter, while radius of the atom is 1 into 10 raised to the power minus 8 centimeter. That means the size of atom is many times more than the size of the nucleus. For an example, if you consider football as the nucleus, then the football ground is an atom. So size of the atom is approximately 10 raised to the power 5 times more than the size of the nucleus. On this basis, Rutherford gave his model. In that model, he said an atom consists of heavy positively charged nucleus where all protons and neutrons are present. Protons and neutrons are collectively referred as nucleons. Almost whole of the mass is contributed by these nucleons, and the magnitude of positive charge on the nucleus is different for different atoms. If we take helium atom, the magnitude of positive charge will be different. If we take nitrogen atom, the magnitude of positive charge will be different. So the magnitude of positive charge differs from atom to atom. Based on these conclusions, Rutherford proposed the model of an atom. Here, this is positively charged nucleus. And around the positively charged nucleus, the negatively charged electrons are moving in circular path. And he compared his model of an atom with solar system. As in solar system, the 9 planets are revolving around the nucleus. Similarly, Rutherford said in his structure of atom, the negatively charged electrons are in continuous motion while moving around the positively charged nucleus. So he called his model as planetary model. He called his model as planetary model and compared with solar system. So what are the applications of the Rutherford model? Based on his observations and conclusions, what are the applications of Rutherford model that we are going to study? First is the volume of the nucleus is very small and is only a minute fraction of the total atom. Rutherford said that size of nucleus or radius of the nucleus is 10 raised to the power minus 13 centimeter, and the size of atom is or radius of the atom is 10 raised to the power minus 8 centimeter. So by this we can conclude that size of atom is 10 raised to the power 5 times more than size of nucleus. So the size of atom is 10 raised to the power 5 times than the size of the nucleus. And when we compare the volume of the nucleus, volume of atom, then volume of nucleus, volume is 4 over 3 pi, and radius of the nucleus is 10 raised to the power, radius of the nucleus is 4 over 3 pi. It is 10 raised to the power minus 8 the whole cube, and the volume of the nucleus is 4 over 3 pi, 10 raised to the power minus 13 the whole cube. So the volume of atom is 10 raised to the power 15 times more than the volume of nucleus. So the volume of nucleus is very small, or entire mass of the atom is concentrated at the nucleus. So he said that density of nucleus is almost 10 raised to the power 14 tons per cc. Very dense nucleus, almost remains same for different atoms nuclei. Then he derived the relation between the radius of the nucleus and the number of nucleons. He said that radius of the nucleus is directly proportional to the cube root of the nucleons, or R is equal to R naught a raised to the power 1 by 3. So R is proportional to a raised to the power 1 by 3, where a is the sum of protons and neutrons, that is nucleons. And when he removed the sign of proportionality, he used constant R naught, which is equal to 1.33 into 10 to the power minus 13 centimeter. So from this expression, we can calculate the radius of any nuclei. If we know the number of nucleons in the nucleus, we can calculate the radius of the nucleus. Once we calculate the radius of the nucleus, we can also calculate the volume of the nucleus. Then the next application is, there is empty space around the nucleus, which he called as extranuclear region. Empty space in an atom is called as extranuclear part or extranuclear region. In this part, electrons are present, and the number of electrons in an atom is always equal to the number of protons present in the nucleus. That is why atom is electrically neutral. As the nuclear part of the atom is responsible for the mass of the atom, he said that entire mass of the atom is concentrated at the nucleus. So he said extranuclear part is responsible for its volume. That means he concluded that the mass is due to nucleus, but volume of the atom is due to the extranuclear region, because volume of the atom is 10 raised to the power 15 times more. And in that volume, which volume of the atom is contributing more? That is the extranuclear region. So the volume of atom is 10 to the power 15 times more than the volume of the nucleus, I have already stated. Then they said that electrons revolve around the nucleus in closed orbit. This is the nucleus and this is the circular path, and he called this circular path as orbit. With high speed, the centrifugal force acting on revolving electrons is the force of attraction between electrons and the nucleus. This was the Rutherford initially performed his experiment. He was not able to offer this explanation, but later on this point was included in the modified Rutherford experiment. So his model was similar to solar system, nucleus representing the sun and revolving around as the electrons as the planets. But in his model, there are certain drawbacks. According to Rutherford, this is the positively charged nucleus, and around positively charged nucleus, the electrons are revolving in extranuclear regions. Electrons are revolving in extranuclear region. So, on this basis, there were certain drawbacks. Whatever model he has proposed, that model was faced some drawbacks. The first important drawback was regarding the stability of an atom. Rutherford was not able to offer any explanation for the stability of an atom. Stability means, according to Rutherford, nucleus is positively charged and electron is negatively charged. So this electron should revolve around the nucleus in definite circular path called as orbits. This should be the path of electron while moving the nucleus. But what happened? Electron is negatively charged, nucleus is positively charged. So in between them, there should be the electrostatic force of attraction. There should be the electrostatic force of attraction. And due to this electrostatic force of attraction, electron will come close to the nucleus. Its circumference should continuously decrease while moving around the nucleus, and ultimately it should collapse with the nucleus. Electron should collapse with the nucleus due to electrostatic force of attraction. But in Rutherford model, this was not happening. In spite of having negative charge, in spite of having electrostatic force of attraction between negatively charged electron and positively charged nucleus, the electron is not decreasing its circumference of the orbit and collapsing with the nucleus. Why this is not happening? Rutherford was not able to offer any explanation for this. So he was not able to account for the stability of an atom. This is the one of the major drawbacks of the Rutherford model. Then second drawback was, if the electrons do not lose due to electrostatic force of attraction, electron should lose energy. If the electron do not lose energy, they might be stationary, but then the electrostatic force of attraction between the dense nucleus and electron would pull the electron towards the nucleus to form a miniature version of the Thomson model. The same thing which I have explained, electrostatic force of attraction should lead to the force of attraction and ultimately collapsing with the nucleus, which is not happening. And second drawback is, the model did not say anything that distribution of electron around the nucleus and about their energy. What are the energies of the electron while moving around the nucleus? What is the distribution of electron around the nucleus in an atom? Rutherford was not able to offer any explanation for that. So these are the important drawbacks of the Rutherford model, which were later on explained by the Niels Bohr by giving his Bohr's model. So before discussing about the Bohr's model, we will study some of the important terms related with an atom. So next we will talk about the terms related with the atom. First is the atomic number. Till now we know this is the nucleus, and this nucleus has the neutrons plus protons, and these are the electrons, and these electrons are present in the extra nuclear region. These electrons are present in the extra nuclear region. So now I am going to tell you about the composition of an atom. Composition of an atom. Any atom, let's consider any atom that has the symbol X. In superscript we write A. A is the mass number. And here we write Z, where Z is the atomic number. But A is the mass number. Number is the sum of protons plus neutrons in the nucleus of an atom. And Z is the atomic number. And this is the number of protons in nucleus of an atom. Or we can call as number of electrons in neutral atom. Number of electrons in neutral atom. That is the atomic number. The atomic number concept was given by Moseley. Moseley performed his experiment and gave the concept of atomic number. This we will study in the next lesson, that is periodic properties as Moseley's equation. Concept of atomic number was proposed by Moseley by performing his Moseley's experiment, and he derived the relation between frequencies of the diffracted X-rays and the Z and gave the Moseley's equation. The detailed experiment we will study in periodic properties. So the atomic number, this is the nuclear charge of the atom, which is equal to the atomic number of that atom. Since the atom is electrically neutral, the number of positively charged protons in its nucleus is equal to the negatively charged electrons moving around the nucleus. यानी कि in atom, number of electrons are equal to number of protons in an atom. Until now, we have studied that mass of electron is very less in comparison to the mass of proton. And entire mass of the atom is concentrated at the nucleus. So, mass of the atom should be equal to the sum of masses of all protons in the nucleus. On this basis, the mass of atom was calculated. But to our great surprise, the mass of atom was found to be double the mass of the sum of the masses of total protons. That means in the nucleus of an atom, there must be some other subatomic particle present that should be neutral, and that mass should be almost same as that of the proton, and this fact led to the discovery of neutrons. We have studied earlier that mass of neutron is almost same as the mass of proton. So mass of the nucleus is due to the sum of the total masses of protons and neutrons, and sum of protons and neutrons is called as mass number. So Z is the number of protons present in nucleus of an atom or number of electrons in neutral atom. And remember certain important point. For neutral atom, the number of proton is equal to number of electrons. For charged atom, number of electrons is not equal to the number of protons. Number of electrons can be greater than number of protons for anion, and number of electrons should be less than number of protons for cations. For example, if we take aluminium, the protons are 13, electrons are 13, but when we remove 3 electrons, it becomes Al plus 3. In that, protons will remain same, but electrons will become 10. So for positively charged species, the number of electrons are less than number of protons. But when we talk about the negatively charged species like chlorine, chlorine has the protons 17, atomic number 17, electrons 17. When we add 1 electron, it becomes Cl negative. Protons number is 17, but electron becomes 18. Yani ki for anion, the number of electrons are greater than the number of protons. So if I ask you, what is the difference between atom and ion? In atom, the number of electrons are equal to the number of protons. But in an ion, the number of electrons are not equal to the number of protons. If electrons are more than the protons, an ion is formed. If electrons are less than the number of protons, then the cation is formed. So, ion number of electrons are not equal to the number of protons. Then second thing, two different elements can have the same atomic number. Atomic number of ions is the same as their atomic number. What is the atomic number of atom? The atomic number of the ions will be also same, because atomic number is basically the number of protons that never changes in an atom. Then number of neutrons is equal to mass number minus atomic number. If we have to calculate number of neutrons in an atom, then that equals to mass number minus atomic number. This is how we calculate the number of neutrons. So, is the protons plus neutrons. For example, if we take the example of aluminium, and asking you to calculate the number of neutrons, then in aluminium, protons are 13. Since aluminium is a neutral atom, so in this electrons are also 13. Now, if we have to calculate the number of neutrons, it is mass number minus atomic number, it is 14. So, how to calculate the number of electrons, protons, neutrons in a species, that we can do. Some of the examples we will be doing. Example, we are taking chlorine 1735. And I am asking you to calculate the protons and neutrons in chlorine. So as I told you, this is the atomic number, which is the number of protons or the number of electrons. Since it is neutral atom, so proton will be same, and this is the mass number. And mass number is equal of protons plus neutrons. So we have to calculate the electrons, number of electrons 13, number of protons 13. Since electron proton is equal to atomic number, then we have to calculate the number of neutrons. It is mass number minus atomic number, it is 18. Now if I ask you to calculate the number of electrons, protons and neutrons in this ion, it is anion. S2 negative carries 2 units of negative charge. In this is atomic number. Now since this is a ion, the number of electrons will not be equal to the number of protons. So first we will calculate protons. Number of protons will be equal to the atomic number 16. We have to calculate in neutral atom the number of electrons should be 16. But since it is carrying 2 units of negative charge, that means it has gained 2 electrons. So total number of electron in S2 negative will be electron. Now we have to calculate the number of neutrons. Number of neutron will be mass number minus atomic number, it is 16. So S2 negative anion will have 16 protons, 18 electrons and 16 neutrons. Let's take one more example of anion. It is Fe plus 3. It is 26 and 56. And this is cation. This is also a charged species. So in this cation, the number of protons will not be equal to number of electrons. So first we will calculate the protons. This is atomic number. So in ion, the number of protons is equal to atomic number, that is 26. The number of electrons, since it is carrying 3 units of positive charge, that means it has lost 3 electrons. So number of electron will be 26 minus 3, that is 3. And if we talk about the number of neutrons will be mass number minus atomic number, this is 30. So in this way we can calculate the protons, neutrons and electrons in neutral atom or in anion or in cation. So once we know how to calculate the electron, proton, neutrons in any species, then we will be moving towards the another topic regarding the terms that we use with reference to the number of electrons, protons and neutrons. So the first term is the isotope. First term is the isotope. But yeah, isotopes are always the atoms of the same element. They will be atoms of the same element. That means they are going to have the same atomic number. And the characteristic property of atom is number of protons. Yani ki if I say that isotopes are the atoms of the same element, that means they are going to have the same number of protons. Isotopes will have the same number of protons. And since we are talking about neutral species, in them the number of electrons will be also same. So isotopes are the atoms of the same element having same atomic number. Same atomic number matlab same number of electrons and protons, but different mass number. So if the species is having different mass number, that means they are going to have different number of neutrons in their nuclei. Different number of neutrons in their nuclei. So can I say that isotopes are the atoms of the same element with same number of protons, same number of electrons but having different number of neutrons in their nuclei. So since the number of protons and electrons are same, isotopes are going to show similar properties. Chemical properties of the atoms are controlled by the number of electrons. In isotopes, since the number of electrons are same, which means they are going to have the similar chemical properties. Since isotopes are having different number of neutrons in the nucleus, so they have very little effect on the chemical properties. Chemical properties are whole solely governed by the number of electrons in the extranuclear region. In isotopes, the number of electrons are same. So chemical properties for isotopes will remain same, but the isotopes will be having different physical properties. Therefore, all isotopes of the given element show same chemical behavior, but they differ in physical properties such as density, boiling point, etc. Physical properties depends upon the total mass of the species. In isotopes, the mass of the atom changes due to different number of neutrons, so their physical properties also changes. So isotopes are the atoms of the same element having same number of electrons, that means similar chemical properties, same number of protons, but they are having different number of neutrons in their nuclei, that is means they are going to have different physical properties. Let's take some example of isotopes. Cl 3517, chlorine 3517 and chlorine 3717. If we talk about proton, neutrons and electrons, protons, electrons and neutrons, first we will talk about the electrons, then protons. So in chlorine, 17 proton, 17 electron, and neutrons will be 35 minus 17, that is 18. And if we talk about Cl37, protons will be 17, electrons will be 17, and neutron will be 37 minus 17, that is 20. So we can see that isotopes are differing in the number of neutrons present in their nuclei. Next example is isotopes of hydrogen. The different isotopes of hydrogen, H11 is tritium, H21 is deuterium, H31 is tritium. So they have the same number of electrons, they have the same number of protons. What is different in different isotopes of hydrogen? That is the number of neutrons. And the first isotope of hydrogen, H11, is the only species which is having 0 neutrons in its nucleus. So that I have also mentioned. H11 is the only normal hydrogen which have number of neutrons 0. Deuterium, second isotope of hydrogen, is called as heavy hydrogen. It is represented by D. Either we write H21 or we write D, which stands for deuterium. But in normal water is H2O. But if we make the water of second isotope of hydrogen, that is D2O, and that is called as the deuterated water. Then isotopes have same chemical properties but different physical properties. I have already explained. Isotopes do not have same E/M ratio. Isotopes have different mass, and due to different mass, their E/M ratio is not same. So this is about isotopes. Next, we will talk about the next term, that is the isobar. Next term is isobar. बच्चे, iso means same or equal. It means same or equal, and bar stand for heavy. Equally heavy. That means they have the same mass. And if the species are having same mass, that means they are going to have the same number of protons and neutrons. And number of protons and neutrons is the mass number. So isobars are the species which will be the atoms of the different element having similar mass number. Since they are having similar mass number and different atomic number, that means they will be always the atoms of the different element which have different number of protons, electrons and neutrons. Isobars will be having different number of protons, electrons and neutrons, and they will be the atoms of the different element. So isobars are atoms of the element which have the same mass number but different atomic number. I have told you they have different number of electron, different number of proton and different number of neutron. But in isobar, the sum of proton and neutron is same. So they have different number of electron and proton and neutron, but sum of neutron and proton remains same. They show different physical and chemical properties. They have different number of electrons, they have different number of protons, so they are going to exhibit different chemical properties. And since they are the atoms of the different element, they are going to exhibit the different physical properties also. For example, we are taking it is K4019 and calcium 40. In this, the mass number of both species is 40, but atomic number here is 19 and here is 20. So if we calculate the proton, it is 19. If we calculate electron, it is 19. And when we calculate the neutron, it is 40 minus 19, that is 21. In this Ca40, protons 20, electrons are also 20, and when we calculate about the neutrons, 40 minus 20, that is 20. Students, can you see that these two species have same mass number, but they have the different number of proton, electron and neutron. Can you see? Both protons are different, electrons are different and neutrons are different. So the isobars are the species or the atoms of the different element which have the same mass number but different atomic number. Another example I have given with reference to the third isotope of hydrogen, tritium and helium. Proton 1, electron 1, neutron 2. It is 3 minus 1, that is 2. Mass number is 3 and here mass number 4. Proton is 2, electron is 2 and neutron is 2. H4. Okay. So next I am talking about the isotones. Isonewtonic species and isotonic species. As the name indicates, isotonic. That means isotones are the species which have the same number of neutrons. Isotones are the species which have the same number of neutrons. So they will be always the atoms of different elements which have the same number of neutrons. For example, let's take the H31 and H42. Proton 1, electron 1. If we talk about neutron, 3 minus 1, that is 2. And if we take about this neutron, 4 minus 2, 2. Since both the species are in same number of neutrons, we can call them as isotones. Similarly, this K3919. If we calculate the neutrons, 39 minus 19, that is 20. And similarly, if we talk about the number of neutrons in calcium, 40 minus 20, that is 20. Since the species has number of neutrons, we can call them as isotones. Next term is isodiphers. Isodiphers are the species which have same n minus p number. यानी कि in isodiphers the number of neutrons and protons is same. Let's take an example of beryllium 9, 4 and boron 11, 5. If we talk about electron 4, proton 4 and neutron will be 9 minus 4, that is 5. And if I take the difference of neutron and proton, it is 5 minus 4, that is 1. And if I take the example of B11, electron 5, proton 5 and neutron will be 11 minus 5, that is 6. And if I take n minus p number, that is 6 minus 5, 1. So they are related to each other as isodifers since they are having the same n minus p number. Next term is the isoelectronic species. As the name indicate, iso means same, electronic means electron. The species having same number of electron are called as isoelectronic species. So if we talk about the nitrogen, oxygen, fluorine, neon, sodium. The Z for nitrogen is 7, oxygen 8, fluorine 9, neon 10, sodium 11. If I talk about protons, 7, 8, 9, 10, 11. To this nitrogen, if I add 3 electrons, it becomes N3 negative. To this, when I add 2 electrons, it becomes O2 negative. When to this, when I add 1 electron, it becomes F negative. When to sodium, if I remove 1 electron, it becomes Na positive. So let's talk about or compare the protons, electrons in all the species. The number of electrons in nitrogen, 7, oxygen 8, fluorine 9, neon 10, sodium 11. And if I talk about the number of electrons here, 7 plus 3, 10. It is 8 plus 2, 10. It is 9 plus 1, 10. Neon already has 10 electrons and sodium it is 11 minus 1, that is 10. So all these species, since they have the same number of electron, I can call them as isoelectronic species. Why I am calling this isoelectronic species? Because they have the same number of electrons in them. So they are isoelectronic species. Example I have given for Cl negative and argon also. Cl negative 17 plus 1, 18 electrons. Argon already has 18 electrons. If I talk about water, hydrogen has 1 electron, 2 hydrogen plus 8. It has total 10 electrons. And if I talk about ammonia, nitrogen has 7 electrons and 3 hydrogen has 1 electron, 10. So these species are also called as isoelectronic. Isoelectronic species may be formed by atoms or it may be the molecular species. Like ammonia and water are the molecules, but they are isoelectronic since they have the same number of electrons. The next term is isostar. Very important term, isostar. But isostars. Isostars are the species which have the same number of electrons. So you can say ki ma'am, they can be isoelectronic also. But isostars have also one thing in common. They have the same number of electron as well as the same number of atoms in molecules. That means they have the same number of electron as well as same number of atoms. Let's take an example of CO2 and N2. In CO2, number of atoms, it is 2 atoms of carbon and 2 atoms of oxygen, 1 of carbon, total atoms 3. And in this 2 atoms of nitrogen and 1 atom of oxygen, total atoms will be 3. So we can see that number of atoms, let's talk about first this. Number of atoms in CO2, 1 for carbon, 2 for oxygen, 3 atoms. And 2 atoms for nitrogen, 1 for oxygen, 3 atoms. Both have the same number of atoms, that is 3. And if we talk about the electrons, carbon has 6 electrons, 1 oxygen has 8, 8 into 2, total electrons are 22. And if we calculate the total number of electrons in N2, nitrogen 1 has 7, has 8 electrons. So students, can you see in CO2 and N2O? Number of atoms, both have number of atoms 3 and number of electrons 22. So isosters are the species which has the same number of atoms as well as same number of electrons. You can ask me, ma'am, do all isoelectronic species are isosters? No. All isosters can be isoelectronic species, but also all isoelectronic species cannot be isosters. Keep in mind what I said, all isosters are isoelectronic, but all isoelectronic species are not isosters. One more example I am giving, that of calcium oxide and Kf. Number of atoms, 1 calcium, 1 oxygen, 2. Number of atom, 1 potassium, 1 fluorine, 2. And we talk about the number of electrons. Calcium has 20, oxygen has 28. And in potassium it is 19 and fluorine has 9, total 28. So since both have the same number of atoms as well as same number of electrons, so these two can be also called as isosters. So students, which terms we have studied with relation to atom? First, we have talked about isotopes, then isobars, then isotones, then isodiphers, then isoelectronic species, then isosters. Now, we will be practicing some of the questions related to these terms. First question, simplest one. Calculate the number of protons, neutrons and electrons in BR 8035. बच्चे BR 8035, these examples we have already done. BR 8035. This 80 is mass number and this is the sum of protons plus neutron, and 35. This 35 is the atomic number and this is the number of protons or number of electrons. So we are asked to calculate the number of protons, neutrons and electron in this. Proton number is 35, electron number is 35 and neutron number is, it is 80 minus 35, that is 45. Okay. Next, very good category of question. If the mass of the neutron is doubled and mass of the electron is halved, then find the new mass of C12 and percentage by which it increased. Bache, all of us know that mass of atom is due to the sum of mass of proton and neutron, and mass of proton is approximately equal to that of neutrons. Mass of the proton is approximately equal to that of proton. So for carbon, the mass number, that means it has 6 protons plus 6 neutrons. Mass of electron is negligible. We have already calculated. So we don't bother about changing the mass of electron. Changing the mass of electron does not affect the mass of atom to some extent. It can be neglected. So if the mass of the neutron is doubled, yani ki new mass of carbon will be, previously the mass of neutron was 6, proton ka mass, so 6, proton mass will be 6, but neutron mass will become doubled, yani ki 12, it will become 18. So mass of carbon doubling the mass of neutron will become 18. So if I ask you what is increase in mass of carbon, increase in mass of carbon will be 18 minus 12, that is by 6 units. So mass of C12 will be 18 and percentage by which it is increased. So percentage increase in mass. Increase in mass. Increase in mass is 18 minus 12. Original mass is 12 into 100. So it is 6 by 12 into 100. That is, increase in mass is almost 50%. If we double the mass of neutron, then mass of the atom is almost increasing by 50%. Is it okay? So now next question is an ion with mass number 56. Mass number 56. And this mass number is the sum of protons plus neutrons. Has 3 units of positive charge. That means if I talk about the number of electrons, they will be 3 less than protons. I said let the number of electrons be x. Then the number of protons will be x plus 3. Since the ion is carrying 3 units of positive charge, that means it has lost 3 electrons. So number of protons x plus 3. The number of neutrons. In the question it said that number of neutron is 30.4% more than electrons. We know it is 1.304 x. This is the number of neutrons. Now in the question what is asked? Mass number is 56. Then proton number is x plus 3. And neutron number is 1.304x. So when we calculate the value of x, the value of x will come out to be 23. And this x is the number of electrons. So in this species, number of electrons will be 23, which is equal to x. The number of protons will be x plus 3, that is 23 plus 3, that is 26. So number of neutrons will be mass number 56 minus 26, that is 30. And we know that atomic number of iron is 26. So what is the representation of this species? It is having 3 units of positive charge. Mass number is 56 and atomic number is 26. This is the symbol of the ion. This is symbol of ion which is asked in this question. So students, in today's lecture we have studied about the different terms. In next lecture we will be starting with the nature of electromagnetic radiation, which is the foundation of the Bohr's model of an atom. So till then,